Hi, I'm Mike Shell with AirTest Technologies. We're a sensor company that makes a wide variety of sensor technologies for buildings. And this presentation today is going to address our new wireless sensor technologies that we're introducing. So let's go on. In this presentation, we're specifically going to give you just a quick background on AirTest and what we're all about. I'm going to give an overview of our wireless technology for sensors and why, for our very first products, we've chosen Wi-Fi as the wireless technology to use. We're also going to talk about, well, once we get the sensor information up on the Wi-Fi, where do we put it? How do you connect to it, and how do you make it work with a building control system or some other method? We'll also just specifically look at AirTest wireless sensors and transmitter products and provide some ordering guidelines at the end, just so depending upon what you're looking for, you do end up picking the right products. And then there's going to be a way that you can come back to us if you have any questions. So first of all, in terms of AirTest, AirTest has been around for about 15 years. We focused on gas sensor technology, which are often considered specialty sensors that are used every once in a while in a building, but they're becoming more and more common. And what we've done is we take sensor innovations that have appeared in the last 10 years and see if there's a way that we can apply that technology to buildings. Generally, what we find is that for most sensor technologies that are most popular, there's generally about a 2-year payback, which is kind of universal in the buildings industry. And those paybacks can be delivered through energy savings, operational savings, safety and liability improvements, or what's a real driver, I think, today is environmental or green criteria. For example, the LEED building certification program now allows you to get points for installing CO2 sensors and actually integrating them with your building control system. So over the years, what we've become is an application specialist, and actually this presentation is probably a good indicator of how we delve into these topics and try and make sure that people understand them. One of the key things we do is we take sensor technologies and try and package them in a way that it specifically addresses needs and problems in the building industry. So if we take a look, the company and I think the industry is evolving from using these sensors once in a while in certain places to really sensor technologies is becoming the next generation energy retrofit for buildings, where a lot of the low-hanging fruit for energy conservation has been implemented in buildings. And now really we're going to an era of buildings 2.0, where sensors and controls are going to have a much more important part in the future. In terms of the variety of sensor products we have, this is really, this section is taken directly from the products page of our website, and you can see all the different types of sensors that are available. I won't go through all these right now, but you can visit airtest.com, just go to the products page and drill down and see what we have there. So first of all, we're going to talk about just generally wireless technologies. And I apologize, this picture is actually a future product we're working on, not available today, but you may see it soon. So coming soon. Okay, so first of all, I want to make it clear that today and for a number of years, AirTest has offered a wired connected solution to CO2. And it's been available in a wall mount, duct mount, and for in-unit mounting as well. We offer a variety of communication options, which include analog 0 to 10 or 4 to 20 milliamp output, LawnWorks, and BACnet. We also offer, in addition to just standalone CO2 sensors, we offer sensors that combine CO2 temperature and humidity. And all the units we sell are self-calibrating. As you can see here, we've categorized in the pictures really 2 categories of sensors, sensors that use background self-calibration and sensors that use a dual beam internal reference for self-calibration. One of the drawbacks, though, that we see sometimes with sensors is if we try and retrofit sensors into a building, the cost of wiring can actually be very expensive, $1,000 to $3,000 per point. And that can extend payback periods out significantly for these types of energy-saving devices. So as a result, we wanted to try and come up with something for particular retrofit applications that would be less expensive to install. And one of the reasons for this is that in existing buildings, that's where most of the energy is used today. And if we take a look at it and we compare the number of new buildings built every year versus the existing building market, the annual new building market is only about 1% of the total buildings market. And existing buildings today are faced with a number of things. They already have rising energy pricing that's affecting their profitability. Building managers in those buildings are highly motivated to reduce operating costs. Usually every year there's some sort of incentive for them to reduce costs. And many of them, as we've talked about earlier, the low-hanging fruit has been picked in terms of energy savings, and they're looking for other things. What we see is we're going to be introducing, and I'm going to be talking about today, really are wireless technology sensors, which can significantly reduce the cost of retrofitting sensors into buildings. And for our very first set of sensors, we've decided to make them Wi-Fi communicating. And there are a number of reasons for that. Number one, Wi-Fi today is really the most widespread and dependable wireless technology used in buildings today, and in homes for that matter. And because of the size and maturity of this market, technology costs are very low, approaching commodity pricing, which helps with the installation cost. We've also found that experience with Wi-Fi networks is very widespread. Actually, anybody over 9 years old generally knows how to set up and troubleshoot a Wi-Fi network. And that eliminates the need for a steep learning curve or training or support getting people to understand how to establish networks. There's already somebody around somewhere who can help with that. Also, from a security perspective, we see that Wi-Fi has a very sophisticated security infrastructure that we can just utilize in our sensors to provide protection against devices and data. The same security measures you use on your PC, on your home or office network can be easily applied to a sensor network in a building. Also, the nice thing about Wi-Fi is there's a ton of options for sending data and communicating with the sensors, and that includes sending data to web pages, to SQL databases connected to the internet, or even using IP, meaning Internet Protocol-based building control systems or online gateways that can translate signals from the sensors into BACnet, Modbus, or LANWorks protocols. As a result, there's just a lot of options for connectivity for when we utilize Wi-Fi. The other thing is that even if, for example, a particular IT manager doesn't want sensors communicating on his network, it's very easy to overlay a separate and totally private network that could work with CO2 sensors and other building control sensors to communicate sensor information to any of the places noted in point 5 of this slide. Finally, I've got to say that Wi-Fi is first, but we're not just focusing on Wi-Fi, and later in 2014 we'll be introducing Zigbee wireless communication sensors, and we're also looking at other protocols like 900 megahertz and N-Ocean. So we're not just focused on Wi-Fi, but we see that as an ideal first step to really make it easy for almost anybody to integrate these sensors into buildings. So first point in terms of our wireless product, the products I'm going to talk to you today are available now, and they include the TR9299 Wi-Fi, which is a CO2 and temperature sensor. This is a wall mount product. We also have the TR9399 Wi-Fi, which measures temperature and humidity, or temperature and dew point. We also have the 9599 and the 9699, which actually can take an analog signal from any sensor, actually up to 2 analog signals per point, and turn that into a Wi-Fi signal that can be picked up and sent to a destination. And finally, we have the TR9499, which offers remote temperature probes. There's a version that only has 1 channel and a version that has 2 channels. And this has applications. The initial target for it was coolers and freezers and retail and restaurant applications, but we're also seeing that people want to use these temperature sensors to monitor motors, to monitor compressors, refrigerant lines, You may even think of some other areas where being able to add a temperature sensor might be useful. As a matter of fact, we were talking to a supermarket chain the other day that wanted to measure temperature in certain ductwork in their system. So all kinds of possibilities for that. Now, the common things with all these sensors is that number one, they're battery powered for 3 years or more. And actually, if you don't want to go out and change batteries after 3 years, you can provide it with a low voltage power input that will just really then make the batteries kind of a backup. What we're seeing is by using Wi-Fi for many applications, you can have savings of $700 to $3,000 per sensor by actually eliminating the wires. And as we'll talk about through this presentation, it's relatively simple to tie these type of sensors into an existing building's control system and wired control network. Also, we'll talk a little about an option to send information to an AirTest hosted website where your data can be stored and analyzed later. So we have sensors that communicate via Wi-Fi. Now, where do they go? Now, again, this picture shows a product we don't currently have available, but maybe one day you'll see it in our catalog or in our website. So it's coming soon. So there are 3 different options that we offer right now in terms of communication to our Wi-Fi sensors. And the first option is something we call the Babel Buster, which is a product of a Minneapolis company called Control Solutions. And it's a very easy way of integrating the AirTest Wi-Fi sensors into an existing wired system or into an existing controller. This product is called the Babel Buster, and basically what it can do is it can take information from our Wi-Fi sensors from a router that's connected to the Wi-Fi system and convert the information sent from the sensors into a BACnet or Modbus control signal. One of these devices supports up to 200 Wi-Fi transmitters. And this is sort of how it works. Let's say we have a network of AirTest Wi-Fi transmitters in a building. It's communicating to a local Wi-Fi router, and then the Babel Buster is actually connected directly into that Wi-Fi router. The Babel Buster actually has a built-in web server with this configuration screen where you can actually define the information coming from each Wi-Fi sensor as to what properties it has and whether it should be looked at as part of a Modbus, BACnet, or SNMP communication protocol. Again, the Babel Buster supports up to 200 devices on the network. So this is a very easy way. If you want to add CO2 sensors, you don't have them, and you want to tie it into an existing building control network, this is a very easy and cost-effective way of doing it. The other option we offer is the AirTest Cloud, and this is ideal for applications where your purpose is really to collect data, monitor systems, and really you're looking maybe to create alarms that if a temperature goes too high or low or CO2 levels go too high or low, you can be notified of it. So this approach is not for control, it's more for monitoring. And this really highly complements the fact that each of our Wi-Fi sensors has a 3,000 point data logger in every Wi-Fi transmitter. So that means that for some reason the signal is lost or there's not a local Wi-Fi signal immediately available, the sensors can store data for a period of time until it comes within range of a Wi-Fi sensor. And so this cloud connection we have is called Point View website, and basically what it can do is it can store and graph data for later analysis. It can provide email or text alarms if certain alarm thresholds are exceeded. And actually, it even supports a process where if somebody receives an alarm, a designated person, they can actually acknowledge that alarm and provide a status update. It also allows, let's say, a supervisor to track the alarm responses, and if somebody hasn't responded to an alarm or hasn't provided an update on what they're doing, then the message can be elevated to the supervisor. This software allows you to adjust a number of parameters of the sensors in the field, including alarm levels, at what interval the data is collected, and at what interval the data is actually transmitted to the website. These are just a couple of quick screenshots of what the web page looks like. This is for account setup, and I won't go into a great amount of detail here. Also, with the system, you can add a number of users so that you can specifically identify certain people who must respond to particular alarms and particular sensors. When you go to the page immediately, what you get is a summary view, and here we have 4 sensors of different types that are listed on the website. A number of information is indicated, including, as you can see on the lower right-hand side there, the battery on one of the sensors is getting low, and there's an indication there. Data is stored at the website, and you can actually select certain time ranges and certain sensors and get a graph of that data. Actually, on this graphing function, you can actually graph up to the output of up to 4 different sensors, and actually you can select a time range or a date range, and actually also download that data directly to your computer. You can also just set how often the devices transmit, and actually at what point they should alarm, and then once they alarm, basically these are examples of email and a text alert that goes out. Basically, you can go back to the as you can see in the email on the upper part, you can go back to the website and actually acknowledge that you had received the alarm. When you do that, basically the sensor is identified as shown here, and you can actually say what the alarm status is, that yes, it's triggered and I'm responding to it, viewed and processed or resolved, and there's even a little text box that the responder can put notes in if necessary. So that's the AirTest hosted website. And then finally, it is possible to send the output of the sensors to really anywhere on the internet. And so this includes data monitoring services, maybe third-party services that are available out there, to IP, Internet Protocol-based controllers, such as the Tritium Jace, EasyIO, or the Can2Go controller. It also can be sent to specific databases on the internet. And basically, when setting up the device, basically each device has to be plugged into a PC. When you're setting it up, you have to log it on to whatever local network it's working on, and then just tell it where it should go. And through this setup, then you can really send this information to any address. The only issue is that the information as it's sent from the Wi-Fi sensors is in something called a compressed user datagram packet, or UDP. That compressed data packet has to be translated into a device-readable format for your controller. Now, most people who are involved in programming these type of controllers know how to write the simple application to decompress this and translate the information. Also, I should add that a link to a description of the UDP spec is available from us, and actually in most of the Wi-Fi product data sheets, there's a specific web link to download that UDP packet spec. Now, one of the issues that comes up that we get asked all the time is the issue of security on these Wi-Fi sensors. And as I said earlier, in terms of encryption, the sensors support all the standard methods currently used on Wi-Fi systems today. It's also important to note that in terms of the transmission packet size, it's very small. So even if you added a whole bunch of sensors to a network, the fact that the size of the communication packet is only 75 bytes means that it's never going to be a burden on the network, especially considering the transmission interval, which can be set by the user from 1 to 10 minutes. Also, the sensors support DHCP, or static IP address. The devices have channel agility, and of course are registered by the FCC CE and are considered IC Class B compliant. The sensors themselves utilize a B or G Wi-Fi radio transceiver, and again, the key here is that even after all this, if you're talking to an IT person and they're concerned about the device being on their network, it is relatively easy to overlay a second separate and distinct overlay network in the building. In fact, we've done this in a few cases where we've even installed our own cellular modem that allows connection to the internet completely separate of what other connections are coming into the building. We also will be coming out actually again this year with Zigbee versions, which can be used if there is a Zigbee network in place rather than using the Wi-Fi network because of IT concerns. So here we now are going to talk a little bit about AirTest Wi-Fi products. And again, I apologize, but these are future products coming. We'll talk about those sometime in the future, but now we'll just look at what's available today. Common features of all the products, the Wi-Fi products that we're offering, are they're battery powered, as we talked about, 3 years. They'll last up to 3, actually I should say 3 years or more on 2 AA lithium batteries that are provided with the sensors. Again, we talked about how they can be low voltage power to avoid the necessity of changing out batteries over time. All standard Wi-Fi encryption methods are available, and the user can adjust the transmission rate, which will affect battery life and can even extend it beyond 3 years if you need more spread out intervals of broadcast. Also on board, as we talked about, is a data logger that can record data when you're not connected to the Wi-Fi network. Each device has an ability to be configured via a PC, and it really has to be configured for it to work. So one of the key things to remember that if you're considering this technology is that you want to buy this special USB cable that plugs into your computer and plugs into the sensor that is used to initially set up the sensor. Once the sensor is set up and you've identified, given it the login information to the Wi-Fi network and where the data should be sent, there's not really another reason that you have to use this cable. So one cable can be used numerous times. And the software that's on your PC, there are two versions, I guess two segments to the software. One is if you're actually going to utilize the AirTest web logging website or our cloud, then there's a wizard that goes through 5 steps where you can set everything up and have the data from the sensor actually sent to the website. Every one of our sensors, if you want to try this out, has 1 month of free logging available where you can actually try out this website and see what you think. But if you want to send the data somewhere else other than the AirTest cloud, there's a manual configuration screen that we showed in an earlier slide that you can set up, again, to log the sensor into the network and decide where the sensor information should go. There's also some other things you can do like this in terms of adjust alarm levels for individual sensors or decide what the measurement and transmission interval should be. And basically, in terms of the CO2 product, and so, you know, we've talked generally about the wireless products. In terms of the CO2 product, it's kind of unique what we've developed here because we're utilizing a very low power CO2 sensor that consumes about 500 times less power than a conventional CO2 sensor. This means that where a conventional CO2 sensor were to run off of 2 AA batteries, it might only last a few hours operating continuously. But with this, by adjusting the interval of the sensor to sample every 2 minutes and broadcast every 10, we can actually get it to the point where this CO2 sensor will last for 3 years in a building application. Again, if we provide 24-volt power to it, it will read continuously and there will be no need for battery replacement. Also to note, there's an interface LED light and button on the front of the unit. that allows you to adjust a few things. One of the features of this, if you want to use it, it does have a flashing light and a buzzer that can be activated if you want a local indicator that CO2 levels are high. Also, I should note that the device has got a back plate on it, and in the back plate is actually you can see a little area there where there's a round silver device. That's actually a magnet that can be utilized, taken out of there and used on the front of the device to actually provide a field calibration and ambient air. And I'll talk more about that in a minute. And that's where the calibration magnet holder is. This is what the inside of the sensor looks like. And these are the main components that if you're using this, you should be familiar with, which includes notably an on-off switch. If you're transporting the device or it's not quite ready to set up, you can keep it in the off position. You can see the optional power input there, which has a wide range of power inputs that it can take, both AC and DC voltages. And then finally, the device does come with a sub base, so the entire assembly can easily be installed on a wall, and there's a screw lock at the bottom that you can sort of see there that holds everything in place. In terms of the PC interface for the TR9299, in addition to the setup, there's a special program that's available that actually allows you to adjust the parameters of the sensor itself. And there are 4 things that you can do with this, or 4 different windows that you can view regarding the sensor. The first is you can actually actively, when you're plugged in, record the CO2 readings. So even if you just wanted to measure in an ambient area, CO2 readings can be recorded and actually logged to the computer that you're operating this on. It's also possible to make some adjustments to the sensor, including its measurement range, if it's going to use background auto calibration or not, and actually you can even set up some of the parameters associated with the background calibration. There's also an adjustment you can make to whether you want the sensor to average or integrate measurements over time, and how much time you should do that, or whether you want to make it very real time. Also, CO2 readings are affected by sea levels, so you can apply that kind of correction to the device. And then if you are going to do the calibration by magnet, you can actually identify when I take it outside, the outside levels are going to be assumed to be, say, 450 ppm. It will also track of when the device was calibrated. Also, if you're interested in actually doing a flow-through calibration, one of the reasons the sensor is designed with that round raised part on the top is that you can easily put a calibration cap over the device. And here you can either expose it to ambient air, flow nitrogen, or flow CO2 gas of a known value to the device and do the calibration that way. Finally, there's just information provided on the actual sensor itself, its serial number and firmware version. So one of the key things about the TR9299 CO2 sensor with that round raised area is we've really made it commissioning friendly. And this issue of commissioning friendly is important because many third-party in many cases now, having a third party come into the building and verify that all the controls and sensors is working is becoming a very common practice. And in fact, many of the new ASHRAE standards, updated standards for buildings, are now really requiring or strongly advising that this type of commissioning take place. And so going in and verifying that a sensor is working properly, that it's reading properly, is part of this whole process. And it's been kind of a challenge as we've made CO2 sensors that current CO2 sensors today aren't designed to be easily verified in the field. And this is really because CO2 sensor manufacturers thought if they allowed for field adjustment, there would actually be more chance of having errors occur because people making the adjustments improperly. But as we found, if somebody in the field can't verify a CO2 sensor is reading properly, it may actually delay transfer of the building and closing of the job. So we offer 2 very simple ways of verifying sensor calibration. And actually, as the text says, it's also a very accurate way of ensuring sensor calibration. The first step is really outdoor calibration by taking the calibration magnet that's in the back of the device and really putting the sensor outside for about 10 to 15 minutes. And then after that period, just putting the little magnet on the upper left corner of the device, it will actually in about 30 seconds calibrate the sensor to whatever ambient concentrations are in the outside air and then assume the value, i.e. 450 ppm, that we showed in the software interface to the CO2 sensor. The other option is to use a bottled gas where you have a gas of a known concentration, let's say 1000 ppm, and basically we have a calibration cap that will fit over the round protruding area of the sensor, and basically you can flow a bottled gas and initiate the calibration using the USB interface and software to a PC. Again, basically the gas should be flown for a few minutes, and then basically the calibration can be initiated through this program. It takes about 30 seconds, and the sensor is calibrated. And if you want, one of the interesting features of this is that while you're doing the calibration, you can actually set up this program to record the concentration so that you can actually have documented proof of the CO2 concentrations before and after the measurement, and that information can be stored to your PC. Now, we see 4 applications, particularly for the TR9299. And number one is under the LEEDS Green Building Program, where points are assigned for various initiatives, green building initiatives in buildings. It is possible to get 1 point for just putting in a CO2 sensor. And at minimum, for this kind of application to get a point, the CO2 sensor must provide an audible and visual alarm. So this is, a TR9299, even if you're not using the Wi-Fi, is a way to actually have a battery-operated sensor that can be placed in the space that provides that warning. Now, with the LEEDS program, it is possible to really get extra points if you're actually doing active monitoring, say hooking this up to the AirTest cloud, or even further integrating it with the building control system. So that's one application for this, and basically if you're, for example, doing the monitoring using the AirTest cloud, that information is available on a real-time basis through any kind of smart device that has a connection to the web. The other thing that the sensor can be used for is actually walk through indoor air quality surveys. Even if there's not a Wi-Fi signal available, one can use the 3072 point CO2 data logger in the device to measure CO2 and temperature readings. So one can actually go around and measure in different spaces. The other thing, there's another feature which is unique to the CO2 sensor, is the little button on front of the device can be pressed to actually timestamp a measurement. So as you're walking around a building and you want to note a particular location, you can actually press that button, and that measurement and its time will be noted in the database. And I guess the key is once within range of a known Wi-Fi network, let's say you get it back to your own home office, the sensor will automatically connect with the Wi-Fi network and upload the data that you've recorded. So it is actually possible. You can do walkthroughs, but you can also do short-term monitoring of, say, 1 to 7 days, where you can actually put the CO2 sensor in, leave it there, bring it back. Again, as soon as you bring it back to your home office, all the data will be uploaded. And one of the things about short-term monitoring is often it's useful to do this kind of monitoring if you're trying to assess whether CO2 sensors are worthwhile or not, because you can really determine if a building is under or over ventilated by doing ideally a 7-day measurement in the space. And then finally, of course, you can integrate these kinds of sensors with a building control system. And we talked a little bit about the Babel Buster and how that can allow integration of the CO2 sensors into the building control system. And again, I think this, for most applications, can be an extremely cost-effective way in terms of installation of getting CO2 sensors in the building. Okay, so another product we have is the TR9399 and TR9389, which basically allows us to measure temperature and dew point or temperature and RH in the space. And one of the reasons that we're offering dew point is because technology has now evolved to the point where this is an easy measure, where a couple of years ago it wasn't. And it's a much better way to control humidity in spaces than traditional RH sensors. And this includes controlling humidity in applications that use chilled beam or radiant cooling, or where it's important to do moisture control in humid climates. Also, if you want to prevent condensation in storage with freezers and coolers and refrigerant lines, dew point is a very useful control parameter there. And of course, just to control dehumidification equipment on air handling equipment that does have variable dehumidification capability. And more equipment now today can be modulated to remove more sensible dry bulb heat or to remove more moisture. Another product we have is the TR9499, which is a remote temperature monitor. As I said earlier, it can be one or two probes that are extended into the device. Typically, the probe is actually the case is located outside of the area that you want to monitor, and the probe is inserted inside. And you can see these pictures below where basically the probes are routed in through the door to a freezer, and then they monitor the temperature of the freezer inside. There are actually three different types of probes that are available for this device, depending upon the application that you want to monitor. One is -40 to 105 degrees C. Another is -80 to 125 degrees C. And another is -200 degrees to 125 C. Also to note, a NIST 3-point calibration is available on all these sensors if you desire, and is available when you order it. And the applications for this include coolers, freezers, incubators, actually a lot of hospital applications. We've seen an interest in data centers where you can monitor the inside temperature of electronic cabinets. Motors and compressors can be monitored. Refrigerant and compressor lines. Actually, we have some people who are looking at actually monitoring the real-time efficiency of chillers and coolers by monitoring the refrigerant lines. And of course, if you want to measure process or duct temperatures, this is an easy thing to add just to give you more information about how the system is operating. We also offer a Wi-Fi analog input module, which can have two analog inputs. One version is a voltage input version, and the other is a current input version. And so you can either pick a 0 to 5 volt input or the version that has a 4 to 20 milliamp output. This makes it really easy if you have a Wi-Fi network, other sensors involved, and you want to add this to the network. This makes it very easy to do. And actually, one of the things we recommend using it for is for our outside air dew point sensor, which can be placed outside. The signal line can be brought into the building from the rooftop. So the dew point sensor is actually on the rooftop, can be brought in, and this transmitter is located in the building where the Wi-Fi network is. And that information for really providing very effective fresh air economizer control can be integrated into the overall building control network. An important thing to note with this process for economizer control is you can use one sensor on the rooftop to actually control all the air handlers that are on the rooftop. So with the CO2 or with the Wi-Fi sensors, there's some things that you just have to remember when ordering. And that is, for all applications, if you're going to be ordering the sensors, you should make sure you have at least one cable and software to allow you to connect to a PC. If you're using the AirTest hosted cloud website, you're going to have to order a web logging account, which actually sets up an account for you, and then order a subscription for your sensors. And you can either order 12 one-month subscriptions or 24 one-month subscriptions or 38 1-month subscriptions. So that means that you'll have a packet of subscriptions that you can use for one sensor, you can use for multiple sensors. If you're integrating into a BACnet Modbus or SNMP network, then you should consider ordering the BabelBuster Wi-Fi to wire gateway, which can support up to 200 transmitters. Again, it's a very easy way to integrate it into a building control system. Now, if you don't want to use the BabelBuster but want to integrate it into another IP device or service, you're going to have somebody write an app to translate the compressed data packets that come from the sensors to the controller. And again, contact us or look at the spec sheet for the link to the spec for these UDP packets, and that should give you enough information to write the translation application. And finally, if you want to do a commissioning check on the sensor using bottled gas, we actually do offer a calibration kit, which includes the gas, a gas regulator, which regulates the flow to the right rate for the sensor, tubing, and a special cap that fits over the sensor. Also to note, you can, once you have the regulator and tubing and cap, if you run out of gas, you can just order the gas bottle. Also to note, available soon will be the Zigbee wireless versions of the product, and they will have the identical product appearance to the products that I've described here and identical function. They utilize the XB Pro radio from Digi, which is highly compatible with most Zigbee networks and systems. There's also a wide number of application tools that are available from Digi to support these type of networks. Also, we will be offering a BabelBuster Zigbee to wire gateway, much like the current BabelBuster we offer, that will translate information sent by Zigbee into a BACnet, Modbus, or SNMP network. I don't know why I can't say that. And it utilizes the same UDP packet format that's used for Wi-Fi, so that if you have your own Zigbee network and you want to write your own translation application, that's also possible using the spec that's available from AirTest. Well, that really covers the presentation of our Wi-Fi sensors, and this page just provides some resources that if you're interested in any of these, you might just want to pause this video for a minute and copy down anything that's of interest to you. I'm including here just the path to our website for the wireless products. Also, if you want to click on or download very simply a link that provides a number of references and white papers regarding this stuff, you can just input www.airtest.com/info.pdf, and you'll get a nice summary document for that. Also, if you want to know more about the cloud logging feature of these devices, there is a download for that. Also, there is a Wi-Fi ordering guide, which kind of goes over a few things I did in the previous slide just to make sure you're ordering the right thing. And of course, you can always contact us by email or phone if you have any questions. Also, please feel free to contact me. And really, at this point in time, if you have any questions or have any application questions, please feel free to contact us and we'll try and support you the best way we can. Thank you for listening. This is Mike Schell, and have a good day.